I want to demonstrate the concept of adding random variables. This would work the same if I was subtracting random variables. So what I want to do at the moment is I have 3 random variables which I've named x, y, and d, and I'm going to perform this operation here. Now, what does it mean that we're going to perform this operation? It means the following: that I'm going to sample from this distribution, this distribution, this distribution, and then once I gather the 3 measurements, I'll add them together. Now, I also want to show that what happens when we do this, what happens to the means. Since I'm adding them, the means will be the sum of all these means right here. So let's try this out. I'm going to go here to data analysis, select random number generator versus number of variables. I'm going to just do this once. Number of random numbers, I'm going to do this 2,000 times. The distribution is going to be normal with a mean of 50, a standard deviation of 6. I'm going to need a random seed here. I'm going to just choose 6. Output range, I'm just going to put this information at this spot. Okay, so this becomes my random variable x. And I have 2,000 numbers from this distribution. If I created a histogram of this, what should I get? Well, I'm hoping to see a nice, well, not a nice, but what the shape should appear to be normally distributed with a mean of 50 and a standard deviation of 6 approximately. Let me now do one for the random variable y. I'm going to come over here and I'm going to go to data analysis, random number generator, but instead of normal I'm going to select uniform, and now the parameters, notice, have changed. These numbers are only going to appear between 20 and 30. Again, I'm going to change my random seed to something else like 526. Output range, I'm going to just put it here. I'm going to click OK, again 2,000 values. And now this numbers come from the uniform distribution. You'll notice that it shows as a minimum and a maximum 20 and 30. So for the standard deviation, the formula to calculate, again, the standard deviation is the following. I'm going to take 30 minus 20 and divide that by the square root of 12. And that's the standard deviation of this distribution. And I'm going to approximate it. Okay. Lastly, the last distribution here is discrete. And here's a table describing there's only 3 numbers that are possible: 12, 10, and 8. Nothing else is possible. And these are the chances of these numbers. So now let me gather a random sample from this distribution. Again, notice how the parameter changes. What it wants here are these numbers. The first column will be the actual values. The second column contains the probability. Again, I'm going to go to random seed to select let me do this one more time here. Random number generator. Just select uniform for a second. And again, I'm going to change my random seed. That's what I like to do. Go back to discrete. And again, what it wants is that set. It's there. Output range, I'm going to put that right here. And now this is D. So what have we done here? I have created 2,000 numbers randomly selected from the uniform distribution, from the normal distribution, and from the discrete distribution. So now I'm going to perform this operation. This is random, this number is random, this number is random. I'm going to come over here. So I'm going to take this number plus this number plus this number, and I get this value here. So this is going to be the new random variable, which is a sum of these three. Now I'm going to come down here and do likewise for the rest of the 2,000 values. Okay, so now the question becomes, what's the mean and standard deviation of this distribution? Well, just to verify, I want to verify for the moment that the mean of this distribution is 50, the mean of this next distribution is 25, and the mean of this distribution is 10.8. Now, I'm not going to get exactly 50 nor 25 nor 10.8, but you are going to see that I am going to get very close. Again, this is not the entire population, it's just a sample from it, but it's such a large sample. So you notice I get 49.89, again verifying that indeed this comes from a distribution whose mean is 50. And I'm going to do the same for the other ones. Again, notice this one should have been 25, I get 24.94, this should be 10.8, and if I round this is 10.8. So again, I verify that this is 50, this is 25, this is 10.8. Now what's the sum of this one? Well, in theory, it should be the sum of these three. $85.63. So now let's see if that's the case. I'm going to come over here and also take the average of this column. So right now this is supposed to be the average, and I didn't even see any difference. So let me try this again. Sorry. Let me do this again. This new standard deviation should be 50 plus 25 plus 10.8, theoretically. 85.8, and again, you can see that that's pretty much what I got. What about the standard deviation? Again, here's the values for the standard deviation for the three distributions. If I were to come over here and calculate the standard deviation of this column, I would get the following. So it says this would be about 6.79. What does my theory say I should get? Well, to find the standard deviation that I should be getting, I'll take this standard deviation, and this standard deviation, add them up. But before I add them up, I have to square each one. So I'll take 6 and square it, plus 2.87 and square it, plus 1.33, and I square it. Now, to find the standard deviation, that's the variance, I'll need to take the square root of this number. And again, notice this is my theoretical value, 6.78. I can confirm that using this sample, 6.79. Now let me do this one more time. But what I want to do is, what happens if I were to look at this random variable, which consists of just sampling from the same distribution 3 times. Now, this does not equal 3x, and I want to show why this does not equal 3x. In algebra, when you do this, you are inserting the same number for each x, but not here when we talk about random variable. When we say random variable, we're saying the following. The sum consists of sampling randomly from the distribution 3 times. Let me do that. We do it again. We do it again. Now, this indicates that we sampled once, sampled again, sampled again, and we add the results. But you'll notice every time we do this, we get a different value for the value x. This changes every single time. So therefore we can't represent this by saying 3 times x. This would imply that we're adding the same number every time, but we're not. We're adding different numbers every time.